Hello everyone, welcome to my channel. Today in this video I will discuss what is the voltage, current and resistance of the conducting wire, and also we will get to know what is the relation between voltage, current and resistance. So let's get started. So as you can see, I am using one conducting wire. This wire can be aluminum or it can be copper. In this wire, we don't know what is the voltage, current and resistance. So let's understand. So this wire consists of a huge number of atoms. Now we'll understand what is the atom. So one atom consists of electron, proton and neutron. So that means a huge number of atoms are available in this wire. So right now there is no current. So we'll understand what is the current, voltage and resistance. If you see here, the electrons are moving from one direction to the other direction like this. Electrons are moving from one direction to the other direction. So due to movement of electron, charge will be generated. That means here electrons are moving from one direction to the other direction. Due to movement of electron, the charge will be generated, but without apply any force, the electron will not move. Okay, so for that we have to apply some pressure. That pressure is nothing but voltage. Once we apply some pressure on this wire, the electron will start moving from one side to the other side and the charge will be generated. So that charge is nothing but a current. For example, we are forcing some pressure, it's nothing but voltage from this side, then electron will start moving from this side to the right side and the charge will be generated. The charge is nothing but current, and current will flow opposite to the opposite direction of the electron. If electron flows from left to right, then current will flow from right to the left. Okay, so now we'll understand what is the resistance. The resistance is it can control the flow of electron. It can reduce or it can increase the flow of electron. So that is nothing but a resistance. Okay. So here I am taking one example with a water tank. This is the water tank, and water is flowing. You can see the water is flowing from this side, and this is the ground. From ground and water tank there is some distance. So in between ground to water tank there is some distance. So that is called a potential difference. And the more potential difference will give the more voltage. So more voltage means the flow of current will be the more, and the less voltage means the flow of current will be the less. So that means if you increase the potential difference, the flow of current also will be increased. If we decrease the potential difference from water tank to the ground, the flow of current will also be the decreased. Okay. In this slide, we'll understand what is the resistance using this water tank. So here the water is flowing. The flow of water is, we can control the flow of water by adjusting this tap. If you tight this tap, the flow of water will be decreased. If you lose the tap, the flow of water will be increased. For example, I am trying to fill a big bucket. So this is the big bucket. I am trying to fill this big bucket. So if I lose this tap, so then the bucket will fill very fast, But if I want to fill one small bucket, I don't want that much pressure. I can reduce the pressure because my bucket is small. So that's why I can control the flow of water due to the small bucket. So here the tap is nothing but a resistance. The tap acts as a resistance. I think you are getting my point. So here tap is nothing but resistance. That means we can control the flow of water by adjusting this tap. So that means by adjusting resistance we can control the flow of current. Okay. Then here we'll understand what is the potential difference. Here I am taking one op-amp circuit. It has two terminals. One is positive terminal, the other one is negative terminal. Positive terminal I am applying plus 5 volt and negative terminal I am applying minus 2 volt. Then what is the potential difference? V equal to V high minus V low. What is the V high? The highest voltage plus 5 volt. And what is the V low? The lowest voltage minus 2 volt. Equal to V high plus 5 volt minus what is the V low? Minus 2 volt. Minus 2 volt. 5 volt minus into minus equal to plus 2 volt. Equal to 5 plus 2, 7 volt. So in this circuit, the potential difference is 7 volt. Means this circuit will give the more current because of more potential difference. Okay. The flow of electron will move from minus 2 volt to 5 volt. Means the electron will always flow from low potential to the high potential. This is the minus 2 volt is low potential and plus 5 volt is the high potential. So that's why the electron will always move from the low potential to the high potential. And the current will always flow from the opposite direction of electron. Means current will flow from the plus 5 volt to the minus 2 volt. Okay. Here we'll understand what is the relation between voltage, current and resistor. Okay. So this is the Ohm's law. What is the Ohm's law? V equal to IR. This is the Ohm's law. So V is voltage, I is current, R is resistance. What is the unit of voltage V? What is the unit of current? Ampere. And what is the unit of resistance? Ohm. Okay. So here I am considering one circuit here. So I am using one battery and this is the circuit with one resistor and V equal to IR. So if you know what is the value of V and R, then we can calculate what will be the current. If you know the V and I, then we can calculate what is the value of R. If you know R and V, then we can calculate what is the value of I. Okay. So for example, V equal to IR, V equal to IR in same line, V equal to IR. The second one is R equal to V by I, V by I. Okay. Third one, I equal to V by R, V by R. Here we are having three combinations. The first combination is V equal to IR, second combination is R equal to VI, V by I. The third combination is I equal to V by R. Now we'll do some experiment for each combination. For first combination, we know what is the R equal to 5 ohm, what is the I equal to 1.5 ohm, 5 ampere, and we'll calculate what is the value of V, what is the voltage. So that means in this circuit we know what is the value of R equal to 5 ohm, what is the value of I equal to 1.5 ampere. Now we'll calculate what is the voltage in this circuit. Okay, so this is the solution. So V equal to IR. We have a I and R value. So what is the I equal to 1.5 into what is the R equal to 5 ohm. So V equal to 1.5 into 5 equal to 7.5 volt. So in this circuit we found what is the value of V is 7.5 volt. The second combination is R equal to V by I. R equal to V by I means we know V value, we know V in this combination we know what is the V and what is the I. We know V and I. Now we'll have to calculate what is the value of R. So R equal to V by I. R equal to what is the V? 5 volt and I 2.5 equal to 5 divided by 2.5 equal to 2. What is the unit of R? Ohm. 2 ohm. So in this circuit, what is the value of R? Equal to 2 ohm. The third combination is I equal to V by R. So we know what is the V equal to 6 volt, V equal to 6 volt, R equal to 6 ohm, R equal to 6 ohm. Now we don't know what is the I. We'll calculate the value of I. So I equal to V by R. I equal to what is the V? 6 volt, and what is the R? Equal to 6. 6 divided by 6 equal to 1. What is the unit of I? Ampere. 1 ampere.